Hey Adam, so this is not correct. The number that goes on top that you need to look for factors of, it's not 72. 2 times 36 are factors of 72. 3 times 24, those are factors of 72. But we're not looking for factors of 72. We're looking for factors of the C term. When you use this X method, what goes on top is A times C, or in other words, 1 times 36. 1 times 36, or 36. And when it goes on the bottom, it's not the C term, it's the B term, the coefficient of the letter, in this case n. This is the number that goes on the bottom. So we're looking for two, and I'm going to use your language here now. We're looking for factored pairs, two numbers which multiply to 36, this part, and they have to add to 72. Alright, determine whether this trinomial is a perfect square, which can be written in this form. If so, we'll factor it. If not, we'll explain why. The answer is no, because there are not factor pairs of 36, two numbers that multiply to give 36, that would add to make 72. So your answer was reasoned pretty well. You just mixed up the 72 and the 36. They should go this way. There are not two equal factors of 36 which add up to 72, but more specifically, to be a perfect square trinomial, we're squaring x plus this question mark, so it's x plus this question mark times itself. That's what x plus question mark quantity squared means, that quantity times itself, which means these two numbers would have to be exactly the same. So if we're looking for two numbers that multiply to give us 36, this term, they have to be exactly the same if this is a perfect square trinomial. And the only way two numbers can be exactly the same and give us 36 is if they're 6. And clearly these numbers don't add to 72. So yeah, the answer is no, it can't be written as a perfect square because there are not two equal factored pairs of 36 that add to give us 72. I hope that helped at least a little bit. See ya. You could also think of this in terms of multiplying these column headings by the row headings. If you put an n and an n here, n times n is n squared, that gives us the first term. And then whatever number we put here and here, they have to multiply to give us 36. And if it's a perfect square, then that number would have to be the exact same thing, so it would have to be 6. So then the question is, if n times n is n squared and 6 times 6 is 36, what will be in these boxes when you multiply the columns by the rows? 6 times n. And for this box, that's n times 6, which is also 6n. When we combine these terms, do we get 72n? Not even close. We've got the n squared. 6 times 6 is 36, we got that term. But the 72n, no, we only have 12n. So if this were going to be a perfect square trinomial, that's our only chance, but we don't get 72n. That's it. I'm going to bed, kid. Take care.